Welcome everyone to another lecture about complex numbers. In this video, we will discuss the process of finding the outcome of a complex number raised to an integer power. The theorem that we'll follow to complete this process is called the Moivre theorem for integer powers. And it is really simple. It says that if we have a complex number in polar form with modulus of magnitude r and phase of argument theta, then the nth power of this number is another complex number with modulus r to the power n and argument theta times n. Remember that the power n should be an integer for this theorem to be applicable. The version of this theorem in rectangular form is just a simple transformation of the numbers from polar to rectangular. We'll find this version useful when we use this theorem in another video in the future to derive some trigonometric identities. Let's demonstrate through a simple example. Suppose we want to find the sixth power of 1.3 at the phase of 70 degrees. 6 is an integer, and so we can apply the theorem. The base number is already in polar form. So by raising it to power 6, we'll have the magnitude 1.3 raised to power 6, and the phase 70 degrees multiplied by 6. This gives 4.826 at the phase of 420 degrees. Subtract 360 degrees from the phase, and we'll get 4.826 at the phase of 60 degrees. And done. This is it. We got our final answer as a complex number in polar form. Let's illustrate the entire thing graphically on complex plane. The base 1.3 at the phase of 70 degrees is this vector here in blue. When multiplied by itself, the magnitudes are multiplied and phases are added. We already learned this from a previous video about multiplying complex numbers. So the 1.3 becomes nearly 1.7, and the 70 degrees becomes 140 degrees. We need to do this 4 more times. Every time the magnitude gets scaled up by 1.3 and another 70 degrees will be added to the phase. At the end, we complete a full round and an extra 60 degrees as demonstrated here by the final vector in green. Let's have another example to make sure that we've got it. Here we are trying to evaluate minus 0.55 plus j.85 raised to the power of minus 99 and represented in polar form. The power minus 99 is negative, but that won't affect our thinking process. What we care about is that if it is an integer or not. And in this case, it is an integer, and so the Moivre's theorem is applicable. To apply it, we first need to write the base in polar form. Then we raise the magnitude 1.0124 to power minus 99 and multiply the phase 122.905 degrees by minus 99. We then evaluate all numbers and obtain a magnitude of 0.2946 and a phase of minus 12,167.6 degrees, which is equivalent to 72.4 degrees if we add 360 degrees 34 times. That's all for this video. Stay tuned for a coming video about roots of complex numbers. But for now, work these practice problems and post your solutions in the comment section. Thanks for watching and stay safe.